Hello everybody, this is Studenger's Cat and welcome to another Codeforces contest. This is Educational Round 122 for Division 2 and today I'll be solving this contest. So there are 40 seconds left for the contest. Yesterday's contest was, I would say I performed bad on A, but then I recovered on C and finally I got a rating change, positive rating change. Let's see today what happens and watch till the end to see whether the cat survives or the cat is killed. Don't know. My rating is currently 1433 and let's see whether it increases or decreases. More than the rating, I would like to concentrate on the number of problems I do. So yeah. Why is this always the case that my A problem always loads up very late? Okay. Change the minimum number of digits in such a way that the resulting number does not have any leading zeros and is divisible by 7. Okay. My n is like up till 1000. Okay. Minimum number of digits in it 4223. Okay, I need to change the number of digits, right? Make if I have okay, I can also decrease, right? My god. Okay, yes. 42, 23, 21, 371. Fine. No. Okay. Like in a range of 10. Wait. Shit. So either the number is like already divisible by 7, and if it is not divisible by 7, we can just modify the units digit to make it divisible by 7. Come on. Yes. I think like A was fine. B. You have a binary string, you have to choose a consecutive substring of S and remove all the occurrence of the character which is a strict minority in it. Fine. From the substring. Okay. That is, if the amount of zeros in the substring is strictly smaller than the amount of ones, remove all zeros. If the amount of ones is strictly smaller than zeros, okay. If it is same, then do nothing. Exactly once. This is the key point. Exactly once, right? What is the maximum amount of characters that can be removed? Problem B. Yes. So if I have a substring like 1, if I choose this, I can remove both the zeros. Fine. So the thing is that if the whole array okay, if I have some 0 and 1, I can't do anything. If I have 1 0 1 0 1 0 1 0 1 0 1 0 1, okay, 1 0 5, right? 2 3 4, and then 1 1. So yes, firstly what we can do is like remove this 0. Array, exactly once. Again I forgot. Yes, exactly once. So exactly once is like, just how many zeros are there in this array? 5. And how many ones? 1 2 3 4 5 6 7 8. Just choose the whole array. Fine. And just remove the zeros. But if I have something like this, 0 0 1 1 0 0 0 1 0 0 0, fine. How many I can remove? I can remove 3 once if I choose the whole array. Is it possible not to choose the whole string to get a better answer? Like I have something like this. Yes. So I have equal zeros and ones here, right? 7 7. If I choose the whole string, it is not possible to remove. So I can just choose one of the, like this or this. Fine. or this one. So in this substring I can remove all the ones, so the answer will be like count of zeros minus 1, else it will be like minimum of the both count, minimum of both the counts. Can I do something more? I can't remove in one operation more than all the zeros, so that is I think the thing what we can do. Do we also require the length now? Yeah. So fine. If c0 equals to c1, c out c0 minus 1, else c out minimum of c0 comma c1. This will work. 0530, that is correct. Is there something which I'll miss out here? If I have a big vector, yeah, removing all is better, I think. Yeah, that is it. Let's try to submit this. Yes, so that was a very easy problem, I think. Yeah, see, submissions are like really high for B as well. C, Monocarp is playing a computer game. In his game, his character fights different monsters. So many problems, so many C problems I've seen in educational rounds, which have the concept of a monster and health and attacks and all. A fight between a character and a monster goes as follows. Suppose the character initially has health HC and attack DC. Fine. The monster has initially health HM and attack DM. Fine. The fight consists of several steps. The character attacks the monster. First, the character will attack the monster, decrease the monster's health by DC. Then the monster attacks the character. Fine. Then the character attacks monster. And it will go on. The fight ends when someone's health becomes non-positive, 0 or negative. Fine. If the monster's health becomes non-positive, the character wins. Otherwise, the monster wins. Monocarp's character currently has health equal to HC and attack equal to DC. He wants to slay a monster with health equal to HM and attack equal to DM. Before the fight, Monocarp can spend up to K coins to upgrade the character's weapon or armor. Fine. Each upgrade costs exactly 1 coin. Each weapon upgrade increases the cost by W and armor by A. Monocarp's character slay the monster if Monocarp spends coins on upgrades optimally? Fine, then we will have HCDC, HMDM, KWA. HCDC, HMDM, KWA. HCDC, HMDM, KWA. Fine. Yeah. Problem. Problem C. Yes. So HC DC, wait. DC HM DM KWA. Fine. This is the character's health, character's defense, character's attack. Attack is DC, right? Okay, attack is DC. For the monster, this is the characters, this is monsters, these are the coins. And if you spend one coin, you can upgrade the health. Okay, this is attack upgrade, this is health upgrade. Fine. If like we can also, okay, so HCDC. Yes. Yeah, okay. Yeah, if I have 25 and 4, then I have 920, then I have 110. Fine. Character's health, character's attack. The dragon's health, dragon's attack. First the character will attack, right? If the character attacks, characters attack. Okay, we can find like how many attacks can the character do. Also, we'll first see the constraints. The constraints. Yes. Yeah. So, okay, these numbers are up to 10 power 15. 10 power 15, 10 power 9, 10 power 15, 10 power 9, then 10 power 5 coins, 10 power 4 and 10 power 10. A is up to 10 power 10. Fine. H 10 power 15. D is 10 power 9. K 2 in 10 power 5. W is 10 power 4 and A is 10 power 10. Very weird constraints, but okay. The most important thing is K, because we have to distribute K into W and A, right? So how many attacks will the monster take to be killed? Monster has life of 9, right? And okay, monster has life of HM, and how many attacks will he take to be killed? That is DC. How many times DC, right? That is DC upon DC, right? Plus HM mod DC is not equal to 0. Yes, this is the number of attacks, the number of times monster will take to be killed. Similarly, the character times, how many times the character will take to be killed, we need to make sure that we want less than equal to, right? Monster will take, yes, monster will take either less amount of times or equal number of times to be killed by the character, right? So if we distribute k into let's suppose we gave some, we can just distribute and check, right? We can just distribute k to some x here and k minus x here to attack, and this must to defense. Fine, if we distribute it in this way, we will have the correct means we can check for each x, right? If we distribute this and check whether it is possible, even if once it is possible, this condition, then we are done. And it is always also given that the sum of k over all numbers is 10 power 5, 2 and 10 power 5, right? I could have done binary search, but this will run in constant time also. Constant hm by dc plus hm dm c dm c character times, right? So now this is just it is not even required, but okay, let us give x to, let us give x amount of coins to, okay, coins to defense is x, so coins to attack is k minus x. Fine. So new mt and ct, we can calculate mt and ct there. So mt is equal to w will be given to attack upgrade, right? W will be given to attack upgrade. So yes, fine. Here hm will become monster, we don't have to change to monster. dc is the attack of the character, right? I'm giving k minus x to attack, right? So dc plus cta times coins to attack times how much attack does get, attack will get w, right? Yes, w. So dc will be changed by this. Fine. And similarly the ct, number of times the character will take to die, will become the opposite, I guess. Yes, dm hc will become hc plus x times a. hc plus x times a, right? If character times is greater than equal to monster times, then just we have to see out yes and return, else we'll see out no. I guess this is it. Yes, no, yes, yes. Yes, no, yes, yes. Fine, this is correct. Let's try to submit this. Yes, that is the fastest C I've ever done, like fastest ABC I've ever done, according to me. What I think. Yes, very good. Let's go to D. So D, fine. D is another question on a problem on mathematics kind of thing. Let us see. You have an array of integers a of size n. Initially, all elements of the array are equal to 1. All are ones. You can perform the following operation. Choose two integers I and x. Okay, I is some index and x is some value, and then increase the value of ai by ai upon x. Fine. After performing the operations, you will receive ci coins for all such I that ai is equals to bi. Bi is another array. You will receive ci coins, and ci is another array, for all such I that ai is equals to bi. Fine, let's take D. Hmm. Okay. D. Fine. So we will paste the problem here. Fine. Yes. So here they say that I'm very confused about the colors every time. Let's take red, or maybe this red. Yeah. So we have an array of consisting of 1 1 1 1 ones, some ones, right? We also have some bi's like b1 b2 b3 and bn, and we also have c1 c2 c3 and cn, right? We have b array and c array. Yeah, whatever. So we need to choose some I, take some I, and do ai is equals to ai plus ai by x. Okay, choose some x comma I in such a way. Fine, this is the greatest integer. Fine, and we need to then tell. Okay, we'll get some ci coins. Ci depends on I. We'll get ci coins in such a way that the number of okay, after performing all the operations, you will receive ci coins for all I. Okay, then this ci, not the ci doesn't depend on this one. What they say is that for each j where aj is equals to bj, we get cj coins. Fine. Your task is to find the maximum number of coins you can receive after performing no more than k operations. At max k operations. Fine. At max we can do k operations, and after performing at max k operations, we need to find the maximum number of coins I can do. Okay. So one of the things which I get in mind is like, let's once get the test case to make it more confirm. Fine. Yes. So I have 4 4. What is 4 4? 4 4 is the n and k. Okay, n and k. N and k. Fine. So my initial array A is 1 1 1 and 1. My array B is 1 7 5 and 2, and my array C is 2, 6, 5 and 2, right? Yes. So yes, so what I can do is like I can choose some x, right? Initially if I want to increment some value ai, if I have some ai is equal to 1, I can only make it 2 if I choose x equal to 1. If I choose any x greater than 1, so ai will not change from, ai will always remain like 1 only, because 1 by x will become 0. Fine. So I can make it 2. So what I can do here is that first I can try to make it 2. Also the thing is like, if once ai has become equal to bi, if once this has happened, then always I'll get ci coins, right? Always I'll get ci coins after each operation, because there's no point in changing ai once I have already made it equal to bi. So first what I can do is like I already have ai equal to bi here, then I can make it equal here 1 1 1 1, then in the next operation I can do 1 1 1 2. Then I need to change one of the ones to 5 or 7. See, how can I change values? Let's focus on that. If I have some 1, I can convert it into 2. Converting into 2, I can then convert it into 0. 2 by x. 2 by x has how many values? 2 by x can be 2, 2 by x can be 1, or 2 by x can be 0. Fine. So I can convert 2 into 4 or 3. Fine. After converting 2 into 4 or 3, means any number x, any number v can be converted from v plus 1 to 2v. Fine. I can convert between all the values. Fine. That means like, if I have a value v can change to v plus, v can be changed from v plus v by x, right? Right. That means if I have a v2, if I have like v as 4, I can convert it to 4 plus 4 by x, and 4 by x can be, okay, 4 by x cannot be 3, right? Yeah, it is not correct, because of the fact that 4 plus 4 by x cannot be converted into, let's suppose 7, because 4 by x is not equal to 3 anytime for any integral x. That means if 4, I can always divide 4 by any of its factors, any of its factors, yeah. Like for example, if I divide 13 by 7 also, 7 is not a factor of 13, but still I can get 2. So 13 can be converted into 15. Sorry, not 2. Like suppose I have, yeah, suppose I have 5 here, then this will become 2, right? However, 5 is not a factor of 13. Still I can get 2. So let's try to see how many values we can get. Yes. Fine. 4 can be converted into 4 plus 4, that is 8. I can convert 4 plus 4 by 2, that is 6. I can convert 4 plus 4 by 3, that is 5. Okay, I can convert into 5, or I can convert, I can leave it as 4, but leaving it as 4 is not counted as an operation. For 3, what all can I do? 3 can be converted into 6. 3 can be converted into 1. So 1 plus 3, that is 4. And 3 can be left as 3. Converting it into 4 is just equivalent to going up. So we can just write like this. Fine. And 3 can also be converted to 6. 5. 8. 6 can be converted into 6 plus 6, 12. Either 12 or 3, that is 9, or 6 by 4. Basically, like, I can convert every number n to n plus n, n plus n by 2, n plus n by 3, up till n plus 1. Fine, this is the values which I can get. 3n by 4, 6 by 4, and basically like n by 2. Okay, 6 plus 6 by 1, 6 plus 6 by 2, 6 plus 6 by 3. 6 by 3 is 2, so I'll get an 8. I'll get an 8. So getting 8 is equivalent to going this. I'll get an 8. Then I can get a 7 if I add 6 plus 6 by 5. That is 1. Like, I can get a 7 also. For 5 I can get 10. I can get 5 plus 5 by 2, that is 7. 7. I can get 5 plus 5 by 3, that is 1. That is 6, right? Yeah, and like this tree will go on further. This tree will go on further, yes. And yeah. So basically we need to like generalize what all values can I get. And like after, and we also need to find how many tries will it, how many operations will it take to reach to a state. To reaching to 5, I can go through 1, 2, 4, 5. Fine. For reaching till 6, I can go like 1, 2, 3, 6. Or 1, 2, 4, 6. Yes. 8. Also, like, let's trace for 8 also. 8 can be made into 16. 8 can be made into 12. Okay. 12. Then 8 by 3 is 2. So I can be it can convert into 10. 8 by 4 is again 2. 8 by 5 is 1. So I'll get 9. Yes, I can get 9. Yeah. Or I can be at 8 also. Fine. So this is the tree. Yeah, I know that this tree is going like little towards the top, but whatever, yeah. So okay. So if n is 8 here, I can get 8 plus 8. Okay, I'm just checking the delta. Or 4. Or 8 by 3. How much is 8 by 3? 8 by 3 is 2. Or 1. Fine. If I had this as 7. Or maybe as 5, right? 5 can be converted into like 5 or 2. Is it like just divide the number by 2 and all the values? I think this is for 6 or 1 also. For 6, no, it is just this vector, right? 5 by 2, 5 by 3 is 1, 5 by 4 is 1. For 6 it can be 6, it can be 3, it can be 2, it can be 1. Yeah, so not always just half, right? If I have 9, 9 by 2 is 4, 9 by 3 is 3, 9 by 4 is 2, 9 by 5 is 1. For each number. Yes, and the numbers can go up till okay. So another thing to note here is like that okay, n is up to 10 power 3, k is up to 10 power 6, bi is up till 10 power 3, and ci is up till ci is just a bonus, right? It is just the coins, doesn't matter, but it is up to 10 power 6. Yes, so the thing is that n less than equal to 10 power 3. Okay, I just have 1000 elements in the vector in the list, and each value, how much is ai's? Achha, it is starting in the starting, it is 1, so it can also go till 1000 only. Fine, can I use like a dp or something and always keep a storage pre-stored? Initially I can store and just keep the values, all the 1000 values, till where will each, how many operations will each value take. That means like, yeah, 1 will take like 0 operations, 2 will take always 1 operation, 3 will take 2 operations, 4 will take 2 operations, then 5 will take 3 operations, 6 will take 3 operations, 7 will take 4 operations, but 8 will take 3 operations. Yeah, all the values, I have 1000 values, right? 1 2 3 up to 1000. All these values need to be known about. So how to find the number of operations required to reach till a number? That is just a pre-computation, right? So can I start with 1, and like if I have a value like 1000 itself, how many different values can it track to? It can be like 1000, it can be 500, it can be 1000 by 3, that is like 334, I guess 333, right? You get the point. Like 1000 by 4, that is like 1000 by 1, 1000 by 2, 1000 by 3, and so on. Like it will become 1 when it becomes 1000 by 501, right? And it will be 2 when it is 1000 by 500. So I'll at max have to check 500 values for each value. Fine, that means like for each value can track up to a maximum of it can track up to any number of values, but I am checking like to check all the values which it can track to, how many values do I need to run a loop on? That is 500 at max. So just run a loop on all the values, and like okay, I can do is like how to do that thing. Sorry. One can be made into two. Okay, I can make a function which can like do a recursion. Do a recursion like fact like I have a function f. Initially I have 1 and number of operations now is 0, right? Okay. In the table this will fill the value corresponding one, like 1 has been 0, 1 has been given 0, then it will call f of 2 with 1 operations, right? And this will fill 2 with 1, and then it will call f of 2 plus 2 with 3 operations and f of 2 plus 1 with 3 operations. This will fill 4 with 2 operations. This will fill 4 with 2 operations and 3 with 2 operations, right? If something is already filled, then I'll just return, right? If it has 0, if it has -1, initially I'll make a vector of integers which will have like 1001 values, each with -1, right? And if it is -1, I will fill it. Otherwise, I will like otherwise I will just call the other value, call the next values, right? So I think the complexity of this will become like each value will only be called once. So it will be like it won't go beyond. Basically, it will be order of 1000, I guess. We can make a vector like pre or dp, I can call it, which will have 1000 values and all -1. Whenever the code will be called, I will do a pre-computation. The pre-computation will be done here. Okay, I'll make a function fill, which will take a value v and int how many operations have already been done. Okay. So if dp of v is greater than equal to 0, we'll just return fine. Else what we'll do, we'll fill dp of v with operations, and then we'll just do the loop. Int value is equals to v and int x, the addition value, right? Addition value is equal to, okay, wait, yes, x is like initially 1, so we'll call while if value by x is equals to 1, right? If val by x is not equal to 1, once it becomes equal to 1, I will just call dp of v with value by x, v plus value by x. We can just call this v, right? And the operations will become operation plus 1. Just for a side check, I am putting like this: dp of v is equal to minimum of dp of v comma the new operations it will take, and then we'll just return Fine. And even I don't think like this would be necessary, but still. And now what we are doing is we have a value v. We'll give v plus x. X is 1, v plus v, that is 2v. Or yes, this will also go and mark all the values in the dp. And some value, is it possible like some values won't be reachable at all? Yeah. And also the things like if v is greater than 1000, we'll just return, we won't need it. Okay, here also I can put a condition. If v plus v by x is greater than 1000, we'll just break. Fine. And here I will also do x plus plus. Yeah. And this vector is just a void, this function is a void function. Fine. So we'll just call fill with dp. Okay, dp is already a global vector. I'll just give value 1 with a number of operations 0. Fine. And let's check. Okay, so we have an error dp. What is the error? Where 162. Fine. Okay. Oh sorry, we have to call the value fill, the function fill. Yes, -1 -1 -1. And then 1 is always acha. Okay, fill 1 0, and then we'll also give like fill 2 comma 1. Then it will initiate all the values. Okay, it says 3 cannot be reached. Can't we reach 3? We had reached 3, right? Yeah, 2 can go. Acha, once it becomes, yeah, that is the case which I missed here. After coming out, we can also give like dp fill v plus 1 with operation plus 1. Fine. Yes. Yeah. So up till 1000, do I have I covered all the values? It is giving, how is it giving like 192, 174, 144, 132. Okay, 96. Okay, let's do this. If dp of I is greater than 10, greater than 12, okay, like it suddenly says like 599 will take 96 times, 96 tries to reach. Will it really take 96 tries to reach? What is the status of standings? I guess D's. Okay. Because of a wrong submission on B. On A, I have whatever, yeah. So yes, why does 599 take so much time to reach? So much time to, so much operations, so many operations. maybe it will take, because 599 is taking 96 operations to reach. How can I get 599? 598 plus 1, right? Okay, it is 598 plus 1, but 598 is, okay, can I do it in, can I do it like this? Wait, fill I plus 1 with, okay, fill one with 0 and fill I plus 1 with dp of I plus 1, dp of I plus 1. Yes, these will take like 12, 13 amount of tries. Okay, fine. So I think I have made the vector like this. Also I can do fill of I. 1 is not needed to be filled. Yes. Okay, if I don't break, what if I don't return? It will take like a very long amount of time. It will take, I think, forever. What if we'll do till 100? Yes. So I assume this is correctly made. In 12 or 13 operations we can reach everywhere. Fine, this is made. Now what I need to do is that the other task, I have made the F. Now what I need to do is match how many operations will each of them require, right? Yes. So for example, if I take this 5 9, okay, k is 9, I have 1 1 1 1 1 and 5 2 5 6 3. Where is it? Yeah, 5 2 5 6 3 and 5 9 1 5 5 9 1 9 and 7, right? This. So reaching till 2 is just the fastest method, right? Yeah, number of operations I'll take to reach here. can be found out by fine. Fine, so I've just taken the inputs now. I can also make one vector, number of operations to reach that value. And then Ri is equals to dp of bi. Fine, so these are the number of operations we'll require. We'll just fine, whatever. Yeah, so we just have made that. If someone requires, okay, now whom to choose, we can choose greedily, I guess. Which value to choose is, that depends upon, like suppose this is ci and this is ri, this is okay, this is c, okay, this is my vector c and this is my vector r, right? It is 2 9 4 6 3 and this is like 4 3 1 2 and like again 1. Fine, so I can do k operations, right? I can do k operations. So if I use some amount of some number of operations on this, I will get, first I can do this, then I can do this. Fine, then I can do two more, these two, then I can do this. Or maybe like, do I need to, in what order should I do the tasks? Like let's suppose, okay, if I do 4 operations, I'll keep on getting 2 coins, then 3,9, then 1,4, then 2,6 and 1,3. Can we do like, can we find the number of, okay, I will do full k operations, right? That is for sure. We will do full k operations. What if like some coin takes less operations to achieve, but its value is very high? Like suppose I had, after k operations, like suppose I had 2, but this coin will take 1 operation, but it will give you like only 2 coins. Fine, so after doing 1 operation, you will get 2 into k minus 1. You will get 2 into k minus 1 coins because of this. But another is like, it will take full k operations, it will take all the k operations, but after the k operations, this will give you, after doing k operations, it will give you some value which is very very high, like suppose 10k. So it will make you earn 10k, right? So what is the maximum what you can do? Can I, or here also should we use dynamic programming? I guess it is not like the fractional knapsack thing, because okay, the return here is can we like can we directly find the return? I guess no, because it depends on when we are doing it. It depends on the number of operations left. Yeah, it depends on the number of operations left after we do this. After we do this shift, is it always necessary to? Yeah, what I'm asking is like, is it always necessary to take one coin, take one I and match the AI with BI then and there itself? I guess yes, because otherwise we'll like delay it. Suppose this AI will take 3 operations to get equal to BI, and this AJ will take 4 operations to become equal to BI. So if I do these 3 operations first and then these 4 operations, so the CI will get CI for will start getting earning CI from this position. It's from after the 3 operations itself. But if I like do them simultaneously, first this, yeah, then I won't save time. I won't basically save time for this, and I will even use my time for this. Means waste my time. So it is better to always start changing one AI and then end it then and there. Fine. But which ones to choose first? So the ones to choose is this will take 4 operations, but it will only give me 2 coins after that. It will start giving me 2 coins after that. That is waste, I think. Fine. This will only take 1 operation, but it will then start giving me 4 every time. What we can do is like we can try starting from this one, then okay. Also the thing is like the constraints of k is 10 power 6. Fine, k is the okay, k is 10 power 6, but each okay, AIs are the values are 10 power 3 only. Fine, and also like the number of values are 10 power 3. Yes, number of values are 10 power 3 and each value is also 10 power 3. Yeah, so yeah, I will have these 1000 number of these things, right? Can I like directly start giving? Yeah, that's what, right? Depends on this. If I start from the starting, how much can some operation earn me? Like if in this case, I had k is equal to, these are the number of operations and this is the number, this is my CI. If I had k as equal to some 10, fine. If I start with this will give me an earning of, this will give me an earning of 6 times to 12. If I start with this will give me an earning of, okay, this will give me an earning of how much? 10 minus 3 7, like 1 2 3 and then 4 5 6 7 8 9 10. 7 times 9 63. If I use up this one, then this will give me This will only take one operation. So 9 4 36. This will take two operations. 8 6 are 48. And this will give me like 3 9s are 27. So I can just choose the maximum value, maximum one, right? This will give me 63. Then k will decrease by 3. K becomes 7. And still I have this whole array. What will happen is k will become 7. Again I'll have 4 2 3 9. 3 9 is gone, right? Once 3 9 is gone, I can just put 3 0. I won't undo anything. Then 1 4, then 2 6, and 1 3. K will become 7 now. K will become 7. Yes, I think greedily I can just choose the best possible maximum. Here 3 6. Here it is 0. Here 1 4, right? I'll remaining with 6 and 4 6 4 24. Then 5 6 are 30. Then 3 6 are 18. So best is 2 comma 6. Like that I can go, and then this will become 5. Then 4 2 3 0 1 4 2 0 and 1 3. So this will only give 2. This will give 0. This will give 0. This will give 1 comma 4. 4 4 16, and this will give me 12. So next I will get this. Am I also getting these in the order of yes, so I guess yes, because if I yes, so it like depends on the total amount it will earn me. First was 63, then 48, then 36, then finally I'll have k as equal to 4. Okay, 46 46 minutes, that's fine. How many D 1300? Is it like we can just sort and then this and then this and then this and then this? Okay, if I had this 4 2 3 9 1 4 2 6 1 3, fine. And if I had only 3 operations, fine. If I had only 3 operations, I could not have used this. So this will become n squared, but it will work, right? Ri's we have ri comma ci. How many will it require? Okay, so now I have ri's and bi's. Which ri and bi should be used? Okay, file k is greater than 0. Okay, what we can do is like we can just iterate over all the values of ri's and okay, I and int profit is equals to, currently I have profit of r0, like these many terms it will take, k minus r0, k minus r of 0 times k minus r0 times the c0, right? And then I can run a loop from 1 to n. And this is basically pose, just to be sure. Yes. Okay, if the new profit, okay, profit I is equal to k minus r of I times c of I, right? If profit at I is greater than the original profit, I'll make pause as equal to, okay, there was no initial profit, right? Okay, I will make position as I and the profit as equal to the profit at I. Fine. Now I know the position where I'll get the maximum profit, right? So I'll make profit plus equals to the profit, the maximum profit I can get, and at the position the number of coins I can earn from that will become 0. Fine. And also k will decrease, right? R of pose, and k minus equal to r of positions. And finally I'll just see out the profit. I will expect some errors. Okay, this is it just running forever? Why is it so? Profit is equals to 0. Yes, we are getting this is working fine. Then I'm getting zeros also, so I'm getting an error here. R pose, right? Can we see how much is R? See out RI and L, and we also don't want this. Yes, 0, 4, 3 and 1. Then 3, 5, 2 is 2, 3, 1. Then okay, and this, okay, fine. So I have already got all RIs, right? So what is the error here? If I have the RIs, Also don't want this loop. Yes. What is the problem here? Let's do cout. P pause and profit. Okay, it has like gone beyond the scopes of everything. Okay, this thing hung. Okay, 0 0 0 0 0 0, just k. Okay, yes. If I just need to print k, it is stuck on 3. Fine. Yes, let's try to just run it for 1. Okay, fine. K will not decrease after 3. Acha, if it is negative, then I won't do it, right? If r of position is greater than k, then just continue. Yes, what is happening is okay, because of the files stuff, it is not working. Actually, I had set up the Sublime ID, which uses the output input. For that reason, this won't work. But why is k stuck? K is not decreasing after 3. 1752 2652 0431 0431. brought in, right? So why is it not decreasing? 1752, 2652, and 0431, right? Ri is equal to 0431, and Ci's are 2652, and K is 4, right? K is equal to 4. Yes. K is equal to 4. Ri is 0. Okay, so when Ri is 0, when Ri is 0, it will always choose. Will it always choose this? Okay, if Ri is 0, I guess it will always choose this. So I have to make Ri is also equal to. I have to also change the Ri. I'll make Ri to some big value like K. R of position. To 1000. Yes. Now I get the answer. Yes. 801381343. I think these answers are not correct. 80138 and 1343. It is like anything. I'm getting anything. Yes. So when K was 4, I got 808. I'm getting profit as 8. Yes. Profit as 8. This won't give me profit. This won't give me. This won't give me. 808, right? And this was 0431. I'm getting 808, then 008. So what is the profit? K profit. The maximum profit is, and position. At what position am I getting the profit? Okay. Why is this 8? That is the position, right? Okay, K and then position is 0. I'm always getting at 0. Why am I getting at 0? I should not get multiple. I should not use same index multiple times, right? Huh. RI. First I got 808. Okay, K is 4. Let us also print RI. Okay. RI. I can also print CI. RICI, right? So if I have 0, 2, I made that 1000. That means I will require 1000 values now. Zero. Okay. Yes. So when I get 4808, 4 I get 4808. K is 4 and I have 8 as the profit. Position is 0 and the profit till now is 8. Then I get K as 4 again. K. Okay, K didn't decrease. Yes. K did not decrease. Then I had to take so confusing. I had to take P yes. Then I had to do I got more 6 profit at position 3. Position 3, right? At position 3, 0 1 2 3, at last position I got. Okay, and it was 6. Okay, how many K's do I have? 4, right? 2 3 4 8 I already have. One more. How can I have only one more? I have this 2, right? Thing is that okay, I have 1 7 5 and 2. Initially I have 1 1 1 1 and 2 6 5 2. 2 6 5 and 2. Yes, in one operation I can do, I already have 2. Then what I can do is like I can do 1 1 1. I can make this 2 and 1 7 5 2 and 2 6 5 2. I'll get this 2 also and this 2 also. Fine. Then what I need to do is like I have done one operation. I have 3 more operations to do. I have 3 more operations, and in 3 operations I can make this 5 also, right? I can make 1 1 1 1 1 2 2 1 7 5 2 2 2 6 5 2. Again I'll get these 2's. Next I can make operation number 1, operation number 2, 3. I'll again do 2 2. And then operation number 4, I'll get 2 6 5 2 and this also, this also, and this also. How much did I get? 1 2 3 4 5. That is 10 plus 2 2 2 2 8 plus 5. That is 23, right? I can earn 23. How is the answer is only 9? How is the answer only 9? After performing all operations, you will receive CI coins for all such I that AI is equal to BI. Yes. After performing all the operations. Oh my god. After performing all the operations. Not after each operation. I was solving like for each. Oh my god. I misread the problem till now. Misread the problem. Okay. after doing all the operations, right? That is like very, oh, I think this is very easy now. That was a tougher version. So I have the RIs, right? So I have one, wait, I have 0 4 3 1. So I have k is equal to 4. How can I split k? I can do this and this, right? So my answer will become 9 here, because 2 5 2 will become 9. But I could have done 4 also, like this. Yes, so I could have done uh, how to choose. Is this knapsack? Yes, this is, I guess this is knapsack. What I have is, I have some RIs, right? Now I need to okay, that is the cost I have, fine. The thing is that I have k size knapsack. Each value has RI weight, and each value has CI profit, and I need to maximize. Yes, this is a knapsack problem. How can we do this? I misread the problem. Okay, so problem D, right? Yeah, knapsack. So here I think I can always delete this whole thing. Just move this underneath. Yes. So I have all the RIs. Let us think fast how to implement the knapsack. Yes. So I have k size knapsack. This is RI weight. I will have okay. When I come to one of the when I come to one of the values, like I have R1 weight and C1 profit, R2 weight, C2 profit, R3 weight, C3 profit, like that, Rn weight and Cn profit. So when I come to I, if I have, so dp of I comma j means max profit if I, like if we, or like let us think normally, R2 R3 Rn, we have C1 C2. If I take, okay, dp of k and 0, okay, dp of k and 0 is basically that if you have either you don't choose this value, if you don't choose this value, you have the full value and you go one index ahead, or what you do is that, or what you can do is like you can just do k minus ri sorry yes, this is 1. If I start with one index, one indexing, yes. Just go to 2 with this much amount of weight. This one signifies from this index till the last, if we have all those elements. Minus r1 comma 2. Okay, so if I have like 4 elements, I have the coins here and the ri's here. So this will take 0, 4, 3, 1, 4, 3 and 1. The costs will become 2, 2, 6, 5, 2, 6, 5 and 2. So if I start from this one, I have only 1, and k is basically w, which is equal to 4. So if I choose this here, 2, 6, 5, 2, right? That means okay, if I start from the last element and the last ri, that means what is r? It is the weight, right? I can choose this value, yes, I can choose, and after choosing, what I can do is that I can just get a maximum profit of 2. Yes, here I can get a maximum profit of 2, because yes, this one is basically, I will choose only one, but if I guess this table is wrong. Okay, why not check knapsack? Zero one knapsack. Full hanging. Dynamic programming recomputation. What is one state? To the value of wi. Okay, 0, 1, 2, 3, 4, 5, 6. Oh, I should fill it with the weights, I think. Yes, not with the weights, actually with the maximum capacity, or what? 1 and 3 minus 2 is also 6. K, how much is k? K is still 10 power 6. Okay, k is still 10 power 6. Capacity, all possible weights from 1 to w. I don't think I'll be able to do it in that weight. If I have 6 weight, right? If I have 6 amount of weight here, Yes. So how many can I take? R1, R2, R3, Rn, right? This will be 10 power 9. It is 10 power 6 times 10 power 3. The weights can go to 10 power 6 and the number of coins can go to 10 power 9, right? That means if I have like 0 weight, 1 weight, 2 weight, 3 weight, 4 weight, 5 weight, up till k weight, and I can give coins like I can earn 2 coins, 4 coins, 3 coins, 6 coins, up till like, let's suppose 6, 7, 8, 9, 10. I have capacity of 10. This is CIs. How much can I earn and how much does it weigh? This weighs 3, this weighs 5, this weighs 2, this weighs 4. Fine. Yes. So if I have like this, if I choose this 4, right? CI RI, if I have full 10 weight and I have this value, I can get a profit of 6, right? I can get a profit of 6. That means I have only I have I have only the first coin, so I can have any profit if I have weight W000. Then once I have get a 3, I'll get all these equal to 2. So in the above problem I had capacity as 4, right? And how many weights do I have? RI I had as 0431 and CI is 2652. So if I have 0 also, I can earn 2 coins. Yes, this is the capacity, right? This first one is the capacity. That means if I have like this one till 4, if I have 0 weight, if I don't have any weight, if I have 0 weight, I can just get 2. If I come to here, I have 1 weight, so dp of I have some weight, j, dp of I and j is equals to okay, either if I choose this, if I don't choose this, I'll get the above value. I'm not choosing this, my weight will remain this much, I get the above value. If I choose this, I have to do like 4, right? If I choose 4, I'll have 2, 2, 2, and suddenly I'll get 6 also, so I'll get an 8 here because of this 2. If I come here up till 3, I'll get 2, but then I'll get a 5 here. 5, and here also I'll get a 5, right? Here I can get 1, I can get 4, 4, 1, right? Minus 1, 7. This is not 5. If I don't include this, I can get an 8. I can get 1 8. If I include this, okay, here what I see is like if I don't include this value, I'll get the above value as 5. If I include this value, I'll get this plus 2, that is 4. So that getting 5 is better. 5, 4, 2 plus 5. Okay, this is not 5, this is 7. Wait. This is 7, right? And I'll get 7 plus 2, 9 here. So 9 is the answer, right? Answer will be using any amount of weights. Here the maximum of this one. But here the fact is like I have dp. I have to make a table which will become of size 10 power 9, and that will be a TLE, and like that will become a time limit exceed, and also like a memory limit exceed, I guess. Operations respectively. Okay. Is there any other method other than deep? Is it not knapsack? Choosing, is it fractional? No. Is it equal to like some, wait, okay, 0 and 2, just add the least ones, which is not correct. Which have the highest density, highest cost per ratio. That is also not true. I have to use dp. I can make an array of like size k, and this will be of size 10 power 3, right? I don't think this will work. No. Can I like sort them according to the RIs? If I sort them according to the RIs, 0 1 3, it will work in this case. But if I have some case like R and C, so my knapsack is of size 4. If I have R 0 1 2 3 4, all values I have, this will give me 2 coins, this will give me 3 coins, this will give me 4 coins, this will give me 5 coins, this will give me 100 coins, or maybe this will give me 15 coins. So in 4 I can either do this I'll always add. I can do this, I'll get 17, 3, even if I have like a 7 here, or a 9 here, maybe a 10 here. So I can 3, right? I can make this 2. So I can choose 2, 2 and 10 to become 14. The ratio is only 3 here. Means this is also 3 times, this is also 3 times. But still choosing this one is better. Basically what I need to say is like, it cannot be solved according to me without it cannot be solved without the knowledge of knapsack, without using DP. This is knapsack. How many people have done D? 1900 already. Means that time 2300. Fine. 3 minutes left. So I think I will not think more upon D, and this is I guess my rating would increase according to this predictor. As of now, I will see how it's okay. I will see how to do D. I don't know still. Can I think more? Like, I don't know. I guess this was it. According to the predictions now, my rating is increasing, not that much, but slightly increasing, around 15 something. It would increase given the fact that I don't fail system test on any of those ABC. And that was it for the video, I guess. Okay, let me cover the solutions part now. Let me cover the solutions for A and ABC. Okay. Solutions. A was like okay, in A, if we want to make any number divisible by 7, either the number is already divisible by 7, so we can do it directly. If the number is not divisible by 7, so if I have a number like 2381, I don't know whether this is divisible by 7, but this is always enclosed between 2380 and 2390, right? It is always enclosed between those two, and in a range of 10 numbers there will always be maybe okay, not 2380, 2390, but I can say 2389, right, like this, right? So I'm only changing the units bit, the unit place, and in these 10 numbers I will always encounter one number which is divisible by 7, right? So if it is not divisible by 7 directly, just iterate through all these numbers and then just find which number is divisible by 7 and then return any. Okay, that was A. Problem B. Problem B. Fine. Yes, we need to remove exactly one okay. If I have a binary, okay, in this I have a binary string. Okay, I can only do the operation at most once, right? Doing the operation exactly once or at most once, like, okay, doing the operation 0 times is not meaningful, so I have to do the operation exactly 1 times. If in the array I choose a small size, I choose a small substring like this, maybe this much, okay, or maybe this much, fine. I will remove some amount of values, right, some amount of ones or zeros, but if I try to include some more values into the substring, it is always possible for me to remove either equal number of 0 ones or more number of zeros ones. Okay, so it is always optimal to start checking for the maximum longest for the longest substring, that is the whole string, right? Once you try to check for the whole string, if for the whole string count of zeros is not equal to count of ones, then our answer is always minimum of count of zeros and count of ones, right? But if count of zeros is equal to count of ones, then what should we do? Like in this, like in this case you have, for example, you have this case, right? You have 1 2 3 4 5 6 and 1 2 3 4 5 6, 6 ones and 6 zeros, right? So if you choose the whole string, you won't remove anything. So then what you can just do is, like, you can just choose this, just remove the first character and choose the rest substring. So now the first character can either be 0 or either be 1. So if initially we had C0 equal to C1, now we won't have C0 equal to C1. That means I got some disbalance. So now my answer will be C0 minus 1 or C1 minus 1. One and the same thing, right? Because both were equal in the starting. Now I will have either answer as C0 minus 1 or C1 minus 1 because both are equal. C0 minus 1 is equal to C1 minus 1. So we can just return any, okay? That was basically B for C. Okay. Yeah. Actually, these problems were pretty easy, so I'm just covering the problems real quick. Let's go on problem C. Okay. Problem C is also an easy problem. I'll show you how I did this thing. Yeah. So in problem C, what we can do is that this is B. Okay, this is C, right? In problem C, I have been given health and attack value of the character, then health and attack value of the monster, the number of coins I can use, and in each coin either I can increase the attack of the character by W or I can increase the health of the character by A, right? So the thing is that this is the number of times MT is the number of times the monster will get killed. How many number of times? Number of times the monster will get killed after. Okay, that is like, it is just the health of the monster divided by the attack of the character, right? And if it is not divisible, then one more, like the seal. Okay, that is just equal to HM by DC, the seal value of this. Fine. Similarly for the character is number of times it will take the monster to kill the character is this, the seal value of this. Fine. So I just need to make sure that this condition is satisfied, that MT is the number of times the monster will take to get killed is always less than or equal to the CT. Fine. So now what I can do is that I have K amount of coins which I can use, right? I can split the K into two parts, into X and K minus X. X means I will use X coins for increasing the attack, and I will use the rest K minus X to increase the defense, right? And I can just iterate over all x's, okay? Iterate over all the x's and find the optimal answer, right? Let me show you the code of C so that you understand more. We are just iterating on the x. That means here, if I do loop, I have the initial values, then I will start these initial values are just for reference. If they are not written, then also it will work. This is the coins to defense. These are the coins used for defense, and these are the coins used for attack. X and k minus x. Fine. So I just calculate the number of times both will get killed. If I get ct is greater than equal to empty, I'll just do cout yes. If nowhere I get a yes, I'll finally print no. That is the output for C. Fine. So these were the solutions of problem ABC. Problem D, I'll just give an overview what I was trying to do. In problem D, I was trying to do, it is not a solution. So if you are here for the solutions, please refer somewhere else. But if you just want to see what I was thinking, then in problem D, it is like I have some, I hope you have read the problem statement, because I'm not going to explain the problem statement. What I tried to do is like, I tried to map like from 1 I can get to which values, because I need to convert ones into some AIs into BIs, and all AIs are initially 1. So finally I want to make those AIs equal to some BI. So in how many operations can I make that AI equal to BI? That I used, I just made a DP, I just used dynamic programming to find that. Like this, fine, basically this one, okay. Like 1 will require 0 operations to be converted to reach 2. We can take only 1 operation to reach to 2. It will take 2 operations for me to reach till 3 from 1, like that, okay. Now for all BIs I can find an RI. So I just get two vectors of C and R. Like this is the number of operations it will need me to take to make AI equal to BI, and after reaching I will get this number of coins finally. Fine. And in total I can always do k operations. When I can do k operations, that means it becomes like a knapsack problem where I have k weight, okay, and I have n items where each item weighs Ri and each item has profit Ci. Fine. But the only constraint which I was facing was that Ki into Ri will become 10 power 9, and that 2-dimensional DP will give time limit exceed and even memory limit exceed. So that I was not able to think like how will I cope up with that. But basic idea what I have till now for the problem is this only. Fine. So that was the conclusion of the contest. I hope you enjoyed the video, and bye bye.